Okay, Chapter 1, Expressions, Equations, and Functions for my Algebra 1 students. We're going to start off the year in the section entitled Variables and Expressions. We've got a couple of vocabulary terms that I'd like you to familiarize yourself with. Take a look at them, make sure you leave some space between them because we'll talk about and write definitions for each and possibly examples. So we've got algebraic expressions, we have variable, term, factor, product, power, exponent, and base. So an algebraic expression refers to sums and differences, products, and or quotients of numbers and variables. So what that looks like is something like 3 plus n, or 4n divided by 6 plus 9. Any variable will do. Variable in this case would be the letters that we're using in accordance with the rest of the numbers. And I can divide stuff and add and subtract, or I could even add more diverse letters, all kinds of things. So these would be algebraic expressions. Notice, by the way, that there's no equal sign here. That will be an algebraic equation, something we'll talk about a little later. And as we just mentioned, a variable is just a symbol, oftentimes a letter. Sometimes we'll use English letters or Greek letters, but sometimes even shapes to represent a variable. The variable is a symbol that represents an unspecified numerical value. The idea of a term is really specific, so I want you to pay attention to the example. The written definition is helpful, but not as helpful as a physical example. So if I have an algebraic expression, such as 3x plus 2y divided by 7 minus 5 plus, 14x squared. If I had something like this, I would like you to know that a term refers to a whole grouping of these numbers. So let's use a different color really quickly. And so I'm going to circle my terms in red. So this is a term. 3x is a term. 2y over 7 is a term. 5 is a term. And 14x squared is a term. I want you to take a look at that and recognize that each of these are separated, by addition or subtraction, and that's what lets you know you have a term. So again, this is a term. What is not a term? Let me see if I can grab another color. What is not a term would be like, you can't separate x squared and say, oh, that's a term. That's not a term by itself. In this problem, 14x squared is a term. In this problem, 2y over 7 is a term, even though it's being divided by that 7. And the reason why I'm pointing this out is because I really want you to have an idea that terms are separated by addition and subtraction, not division and multiplication. Okay, so factors, this is a word you've used before. And here we see a slightly broader definition because we're talking about numbers or variables that multiply to produce a product or to produce a number. So for instance, if I had, I don't like this color, let me change that. For instance, if I had 3x times 5, let's say, and we know 3x times 5 would be 15x. The factors of this problem are 3, x, and 5. The product is here. So these guys are factors, and this is the product. And that, of course, leads us directly into the definition of the word product, which is just the answer you get from multiplying factors together. Power does not need to be capitalized. Sorry about that. Sometimes the program capitalizes things that I choose not to, but power is basically an expression involving an exponent, and oftentimes it specifically refers to an exponent. So if I have 3 to the second power, in this case 2 is the power. And I can write power. There we go. Another name for exponent, or another name for power, is exponent. So it really is the little number that indicates how many times I'm multiplying the base. So in this case, I've got 3 to the second power, which means 3 times 3, 9 to the fourth power, which would mean 9 times 9 times 9 times 9. The term base is used to refer to In this case, the number 3, the number that is being raised to an exponent. So 3 is the base, 2 is the exponent, or power. Sometimes power is used as well, as we talked about before. Okay, let's take a look at these first example. We're going to write verbal expressions, and basically we're translating algebraic expressions to verbal expressions. So if we look at this first one, we can simply translate that as 3 times x to the 4th power. Part B is 5 times z to the 2nd power plus 16. I know this seems really elementary and I know it seems basic, but it's really important that you can understand exactly what's being asked of you when you look at an algebraic expression. So let's do the last one. C is 1/2 times A plus 6 times B divided by 7. This is a handy chart that's going to really be of assistance to us working through and helping us understand what phrases mean and how to translate them. So I do want you to take a look at this, copy it down. Sorry about this. I don't know why that happened, but that word is multiplication. So addition, words that we use when we're talking about addition would be total, sum, plus, increased by, added to. Subtraction, less than, subtracted from, difference, decreased by, minus. Multiplication, the word product of, and we talked about product being the answer to a multiplication question. So product of, multiplied by, times, of. Now this is a little tricky. I don't like saying that of means multiply, but the reality is oftentimes when you see the word of, 1/2 of, or 2/3 of, oftentimes it does imply to multiply. And then finally division, the word quotient or divided by will be used. Let's use this for the next example. In example 2, we are required to write an algebraic expression. So we're writing these expressions given this verbal information. Let's take a look at part A. A number t more than 6. A number t more than 6. So we know the word more than indicates addition, so we recognize that we're going to take 6 and we're going to add t to it because this number is t more than 6. 10 less than the product of 7 and f. 10 less than. When something is less than, you are taking away or you're subtracting. If it is 10 less than, I'm going to subtract 10. What are we subtracting 10 from? 7 times f. Remember, I don't necessarily have to write a multiplication symbol when I'm multiplying a variable and a number. I can just put them next to each other, and that means multiplication. Finally, part C, 2/3 of the volume of the volume V. 2/3 of the volume V. So it's 2/3 of something, and we remember the word of doesn't mean multiply, but it often implies multiplication. So we write 2/3 V. 2/3 times V. In example 3, we have something that looks a little crazy because it doesn't seem like it has enough information, but we can handle it. In this example, it says write an expression. So Mr. Martinez ordered 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. So he's ordered 2 different things. He's ordered some keychains and some pencils. Write an algebraic expression that represents the cost of the order. So there's some unknown information. If we needed to calculate costs, we recognize the need to know how much each keychain costs and how much each pencil costs. Those will be our variables. So the first and most important thing for us to do is to define our variables. Realize that our variables really need to make sense, and to define them is important. Putting C is cost and P is cost doesn't work. We need to say what it is the cost of. And to say C is keychains and P is pencil is not acceptable. Every time we define a variable, we must make sure that it represents the numerical value that we're interested in. So I define C as the cost, C is the cost of each keychain and P is the cost of each pencil. So now our expression looks like this. If each keychain costs if each keychain costs C amount of dollars, then we know it's going to be 250 times C plus 500 times P, where P is the cost of each pencil. And this is the expression we're looking for. Okay, so your assignment is pages 7 and 9. You can check it out in your packet. I'd like you to do problems 19 through 29, all 31 through 33, then numbers 35, 40, 41, and then 51 through 55. We'll do whatever we need to do in class to get that done. Have a good one, guys.